water, atmosphere, and hydrosphere. So we have some space for the for this compartment. So what's about the biosphere? Do we need any space for the biosphere, or it can be anywhere? Can you people answer? Like, it is a tricky question, but you people can answer it. Today's topic are in syllabus of Danish. He has advantage now. Okay, and I also have some advantage because my graduation was in like botany and some kind of ecology, and we also have some ecology part here. So I will have some confidence while teaching you people. So Danish, what's the biosphere?
Ma'am, biosphere is the interaction between the all spheres of the Earth, like the hydrosphere, the lithosphere, and atmosphere, where the living, where the life sustains.
Okay, yes. So it can be the part of atmosphere, it can be the part of hydrosphere or the lithosphere where where the life can survive, right? So we will talk about biosphere. Okay. So let's talk about soil first. The definition of soil we have is it is a collection of natural bodies on the earth's surface containing living matter and supporting or capable of supporting plants. So we have some natural bodies on this earth's surface, and we must have some living matter in it. Okay, and if we have a soil, it must be like either it is capable of supporting plant or it is supporting the plants. So let's say we have the desert and we don't have the plants on it. Okay, but it may be possible that the plant can be grown on this in this soil. So this is like it is capable of supporting the plant, but it may be possible that we don't have right now plants on it. Okay, so the definition says it is a collection of natural bodies on the earth's surface. We must have the living matter in it, and it must be capable or supporting this plant's growth. Okay, the second definition we have for the soil is it is a mixture of rock debris, because here we can see the 46% of the component of soil we have the mineral. Okay, so it is a mixture of rock debris and organic matter which develop on the surface of earth, and it is a medium. We already have talked about that it is a medium that supports plant growth. Okay, so from where these minerals come? So what's the difference between rocks and minerals? So can Kuldeep? Yes.
Ma'am, the difference between mineral and rock is a rock is composed of one or more than one mineral, and a
Yes.
uh, mineral is maybe one element or a composition of different elements. It should have a composition of chemical,
In a definite manner, right?
yeah, yeah, ma'am.
Okay, so if we talk about some minerals, so we must have some formula for it. Okay, if it is a feldspar, if it is a mica, we have some formula for it, because each element have some proportion in the minerals. But if we talk about the rocks, then this is made up of minerals, and the composition can be vary. Okay, so we don't have the definite composition in the rocks. Okay, so because we have the four components of soil, that mineral, a large chunk has been covered by mineral, 46%. Then we have water and air, 25%, and we have the organic matter in it. Okay, so these are the four components. And from where this mineral come in the soil? Obviously, you can
Ma'am,
answer.
due
From
to
Earth's
weathering and
surface.
Danish, what was the answer? From where this
Ma'am,
mineral come?
sorry, from Earth, uh, inside the Earth.
Inside the earth, or you can also say that from rocks, right?
yeah, ma'am, weathering of rocks.
Yes, ma'am.
Weathering of rocks. Okay, so we will
Magma
also talk
rocks are
about,
formed.
Yes, we will talk about weathering of rock as well. Okay, so how this soil formed, you already have discussed. It occurred through weathering of rocks and deposition of organic matter, because we know that we have minerals and we also have the organic matter. So we can't neglect this organic matter also. So it is a weathering of rocks plus the deposition of the organic matter over time. So it depends on various factors such as parent material, the relief, the climate, vegetation, human activities, and time. So Kuldeep, you will tell me like how this parent material is playing very important role while deciding this soil formation. How the parent material can do such type of actions.
Yes, ma'am. Ma'am, we have numerous rocks uh,
Yes.
found all over the globe, and
Mm-hmm.
they are, metamorphic, sedimentary, or igneous. So the weathering of the rock, like it is, if it is sedimentary, then the composition, porosity, texture, color of the soil will will be different. And if it is basaltic, then the water holding capacity will be low.
Yes,
Uh,
yes, exactly.
there
And
are many.
even we can also talk about the like easiness of withering process. If it is a like soft rock or soft mineral we have, then the withering process will be easy for us, right? And if we have the hard rock, then the withering process will be difficult and the soil formation will take a lot of time for that. Okay, so yes, you defined it well, because parent material, it may be like silica rich, it may be like because this for soil formation, the pH of the soil, everything depend on the parent material, if not completely but the partially. Okay, next, the relief. So how relief also plays some roles? Can anybody tell me? Danish, can you guess?
Ma'am, can I tell? Can I answer?
Okay,
Ma'am,
okay,
I
okay,
didn't
yes.
get your voice.
Okay, my voice is not clear to you.
Ma'am,
Ma'am,
it's clear for
actually
me.
here it's raining, so I think it's my network issue. So could you please repeat?
Just like parent material, I wanted to know how the relief can change the soil formation process, or how it can like based on this relief, how our soil have a different properties. Danish, what happened?
Uh, Ma'am, may I answer this?
Yes, please.
Ma'am, basically, relief, we refer to the slopes and the steeps of the that certain topography or the piece of the land. So it
Mhm.
basically plays a very important factor in soil formation with like steep slopes like the hilly region or the edges of plateau. So it basically barrens the slope from erosion, and sometimes it also like hinders a soil formation in some like phases, but we can say that it makes a barrier for the wind carrying the like debris which accumulates and makes soil or the soil erosion.
Exactly. And we can also tell, like, if we have a relief, then this geomorphic agent, that water, someone wants to join. So the geomorphic agent, that, for example, water, it basically works on the relief. Mostly works on the relief, because if we have relief, and the speed of water will be high on this high altitude, when we have the steep slope. So the formation of soil is also depend on this relief. Then we have the climate. Uh, in this climate, we have temperature and rainfall. So the decomposition, everything depends on how much rainfall we have, how much temperature we have on the on the rocks. So based on that as well, we have the soil formation that's being depending on this factor. So also we have the vegetation. We will discuss it in the next slide. Then the human activities. So Kuldeep, can you explain how these human activities can play a very important role while forming the soil? Can you guess?
Yes, ma'am. Human activities, obviously, ma'am, we know they play a major role. Like we are
Like if we are
mining.
doing mining, exactly, if we
Yeah.
are doing minings, then this soil formation process can be very fast. Is it possible?
Um, Actually, ma'am, the top layer is the soil. Actually, the crust's top layer is soil. If we are doing
Mm-hmm.
mining in the region of like plains,
Mm-hmm.
then we are actually
Eroding the things.
eroding. Yeah, so it's not good for environment or the vegetation in that area. If we
Okay.
are doing it
But
on a relief, then
mhm.
also it's not in nature's favor.
Okay, but as we are discussing about the soil formation, how these human activities can change or can lead to the soil formation or make changes in the soil formation. So yes, if we are doing some activities such as like if we are building something, we are just crushing the stone, we are doing the mining, so then we can also say no, ki weathering process is now anthropogenic. And if the weathering of rock is happening by the humans, then it may form the rock rapidly as well. Okay, so in that way as well, we have the human activities on which the soil formation depends. Then the time, if we have a lot of time, so we will have the fine grained soil. But if we don't have some time, we have a shortage of time, then we will have some grained structure soil. Okay. Okay, so you people already know about this weathering, because weathering is an important phenomena. Because if we don't have the rocks, if we don't have the weathering process, how this soil will form? Okay, so we have two different type of weathering process. One is physical and second is chemical. We also have third category, that is the biological. But biological make use of this physical and chemical weathering. So we are not taking into consider right now the biological weathering. Okay, so in the physical weathering, this is the disintegration of rocks. Rocks are being breaking down. And if we are talking about the chemical weathering, then there is the decomposition of rock and mineral. So the disintegration and decomposition, these are the two different words that you have given your mind. Then in the physical weathering, we have the wedges, the pressure release fracture, freeze thaw, plant roots. This you can see here. We have the biological weathering, that is a part of this physical weathering. Then exfoliation domes. Then if we talk about the chemical weathering, we have the dissolution, hydrolysis, oxidations. Okay, so let's start with the wedging. So what do you mean by wedging? Mayank, are you here?
Yes, ma'am.
Okay, so what's your background? Like, are you the geography student or from some other field?
Actually, ma'am, I am from computer engineering department.
Uh, Okay, so you are from computer engineering. So, okay, you know about this terminology, weathering and physical or chemical weathering and something like that.
Yes, ma'am. Yes, ma'am. I'm
Okay,
understanding
so
these terms.
okay, so if we have a transition of temperature, okay, if we have warm temperature in the daytime and night, and at the night we have the cold temperature, so what will happen? So it will also create weathering. So how this will create weathering? Kuldeep, can you explain? And what it is known as?
Yes, ma'am. Ma'am, as you told that the temperature during day is hot and during night it's cold. So the rock is shrink during night and it expand
Yes.
during day. Yeah, because of sunlight and high temperature. So it makes some cracks. It develops some cracks, and these cracks get bigger and bigger. So finally it causes the weathering, which is
Okay, yes.
weathering.
Okay, then because it will create some weathering when we will have the cold temperature and warm temperature, like if we have the contrast of temperature. In addition to that, we can also say that because of this cold and warm temperature, there will be a stress on the upper layer of rock. Okay, and this, because of this stress, we will have some the exfoliation, like the removing of the upper layer from this rock. So this will also create the withering process. So here we can see exfoliation domes. This can also formed by the this temperature contrast. And we talked about the temperature. Okay, let's talk about this freezing and thaw. So when we have water in a liquid state and in the solid state, so how the changing the state of water can lead to the withering? Danish, can you explain?
And basically, when we have a crack or a fault in the land and the water, there is a water present, and suddenly the temperature drops down. So basically, the water freezes, and it exerts pressure outwards. Basically, it becomes
Why?
solid, ma'am, because
Why
it
it? Why it? Yes,
and because it
yes, please.
changing its state, it's becoming solid to liquid to solid, and the particles are getting more concentrated. So that's why
Uh,
they are.
can you explain in term of density? If we are changing the if we are changing the state of that water from liquid to solid, what will happen with this density?
Ma'am, as I know, the density of water is heavy in comparison to like land. So I don't have much idea about it.
Will decrease, ma'am. He's right.
I think yes, ma'am, it will decrease.
Okay, so when it changes from liquid to solid state, we will have the ice, and ice have the less density, and
Yes, ma'am.
less density it will expand, like the volume will be expanded. Okay, so because of this expansion that you already told, that it will create some pressure outward, and because of this pressure we will have the crack, and this will crack will become deeper and deeper, and after some time we will have the rock broken, right? This is what you want to say?
Yes, ma'am.
Okay, then this plant roots, because this plant root will penetrate the rock, and because of also that, the crack will become deeper and deeper, and that's why this physical weathering will also take place. And Kuldeep, what's this pressure release fracture?
Ma'am, no idea about it.
Okay, so if we suppose if we have one rock and above it we also have one rock. Okay, so there is some pressure on the below rock, and if we remove one rock from here, then what will happen? It will like the pressure on this below rock will be released, and because pressure will be released, it will create some changes on the surface of this rock, and based on that this physical weathering will also take place. So this is all about the physical weathering. If we talk about the chemical weathering, we have the dissolution, when some mineral dissolve in the water. Okay, we have the hydrolysis, when water react with the minerals, and oxidation, when obviously oxygen react with the minerals. So these are the different kind of chemical weathering as well. So whenever we have a rock, then this rock will be will be changed into this minerals because of the weathering. And if we have the minerals, then it is possibility that soil can be formed if we have the organic matter in it, and obviously with the weathering we will have water and air in it. Okay, so And the most prominent rock that take place while soil formed are quartz, this calcite, feldspar, and mica. Okay, let's talk about the soil separate. So the one question from my side is that we in eighth or ninth class we had one chapter in the biological that the smallest unit of life. So what was the smallest unit of life?
Cell.
Cell, yes. And if we talk about in chemistry, what's the smallest unit in chemistry?
Atom.
Atom.
Atom. Okay. And if we are talking about soil, so what is the smallest unit we will talk about mainly? It is the
Clay.
soil separates. No,
Clay.
it is
Clay.
soil separates. Okay.
Okay.
So just like cell, just like atom, we have the smallest unit of soil, which is separates. Okay. And we have three type of separates, that is sand, silt, and clay. And this is based on the particle size. And if we have particle size more than this 2 mm, this will be the gravel or pebbles. We will not classify it into the soil. Okay. So if we have sand, the size of this sand is from 0.05 mm to 2 mm. Then if we talk about the silt, it is 0.002 mm to 0.05 mm. And clay has the smallest particle size, that is less than 0.002 mm. So keep in mind, we have a smallest unit of soil, that is soil separates, and we have in it the the sand, silt, and clay. Okay, so based on the combination of these units, either we have like what proportion of sand is mixing with what proportion of silt or what proportion of clay, we will have the soil texture. And soil texture is nothing, it refers to the feel, appearance, or consistency of the soil. So how it feels when you have a soil in your hand. So when you rub your finger and in between that you have the soil, so how will you feel, what type of particles you have in between your finger. So this is kind of texture. Okay, so it is determined by relatively proportion of clay, silt, and sand. Okay, and it influence soil porosity, permeability, infiltration, shrink swell rate. We will talk about it later. Water holding capacity, susceptibility to erosion of the soil. So one question from my side is that which type of texture is most fertile? Can you guess, Kuldeep? So we have okay, so we have clay, we have sand, we have silt. Okay, and there is a combination. So here we can see, if we have a large portion of clay, then we will know it as a clay. A loam is a combination, equal proportion combination of clay, then sand, and silt. Okay,
Ma'am,
we
uh,
also know, yes, Kuldeep.
ma'am, loam will be the most fertile soil texture.
Okay, okay, why?
Ma'am, because it has combination of all these three. So uh,
Yes.
so it will have permeability, it will have porosity, enough porosity what is needed, and also it will have water holding capacity.
Okay, you can also say that because sand type of this texture has some disadvantage, and likewise clay and silt also some have disadvantage. And when they are in some combination, then the productivity of the combination will be the greater. Okay, so because loam has the equal proportion of this clay, sand, and silt, so all the good properties are coming together in the loam. So for the if we are talking about the fertility, then obviously loam soil has the advantage of this being the fertile soil. So these are different type of these are the different type of texture we can talk about: silt, loam, clay, loam, based on the proportion of these three different units. Okay, so because we already talked about the soil's smallest part, but what happened if they come together? So my one question is that, because you talked about the cells is the smallest unit of life, so when similar type of cells come together, what it is known as? Mayank, can you
Tissue.
guess? Oh, Mayank is also here. Can,
Yes, ma'am.
yes, what it is?
Tissue.
Yes, yes, exactly. So we have tissues. Likewise, if we have like different units of Danish, it's all right. So if we have different units that are coming together, aggregating, clumping, so we will have some other structure. So this structure is the soil structure. So arrangement of solid particles, solid parts of the soil and the pore space located between them, and it is determined by clumping, bind, and the aggregation of uh, soil granules. Okay, and it influence water and air movement, biological activities, root growth, and seedling emergence. So here we can see if we have the granule structure. So we have the rounded granules, and these rounded granules are coming together. So we can see here we have the much air pores or the spores in between that. So this is the granule structure. If we talk about the prismatic, so we have the prism-like structure that are coming together. Likewise, we have the blocky structure, platy structure. Then we it may be happen that we don't have some this type of soil structure. So this is the single grained. Then we can have massive and the columnar, and we may have different type of structure. This is not the limitation. This is not the limit. And I want to talk more about this platy because we talked about the clay soil. So clay soil is organized in this platy form, and here we can see there is no no or very little air space, and because of that we will have some different property of clay. If we talk about this granule, then this is a kind of like the collection of this sand granules together, and because of that there is a more air space. Okay, so because right now we know about the units of the soil, the smallest unit, then we also talk about the soil structure. Then based on that, there is some soil properties. So what it is? If we talk about the water holding capacity, then sand has the lowest, but clay has the highest. So why it is? Danish, can you tell me why this clay has the highest water holding capacity, but sand has the lowest?
Ma'am, because as you told in the earlier slide, that particles of clay are very fine and very small, so they bind together so well that they are they made a very concrete type of structure. That's why
Yes.
it has a high water holding capacity.
Yes, water holding capacity is basically based on the air spaces we have, and I already talked about it because clay is the smallest particle we have among the soil particles. So, because these particles will come together very closely as comparison to this sand and silt. So for the sand, we have low holding capacity. For the clay, we have the highest, and silt, we have the intermediary. Okay. And because we talked about the airspace and the pores between these particles, this can be explained with this aeration as well. Because if we have some way to go through, then we will have the aeration facilities. So because sand has the particle size bigger than this clay and silt, so aeration will be good in the sand as comparison to this clay. Okay, and this pore space also define this drainage rate as well. Okay, can anyone tell about me the capillary action of the clay and sand? Mayank, can you tell me? What is
Uh,
the capillary action or the capillary rate?
Capillary rate.
You know that
If
whenever
we
you are a
mean
wet,
pressure
you use
difference.
the towel, right?
Yes, yes. Due to pressure difference, high to
It
low
is
pressure difference, there is movement of that liquid that is contained in the towel. So
yes.
there is a movement of that substance from high to low pressure.
Okay, yes. And we can also say that if we have the particles that are closed together, then we will have the high capillary action. Because of that, they have the pressure gradient. Okay, but in the sand, because we have some space, it don't create the column of this capillary action. So that's why the drainage rate of this sand is high, but for the clay, it is very slow. Okay, let's talk about soil organic matter level. This is because we know that clay have some minerals in it that make some complex with the organic matters. That's why in the clay we have the high to medium soil organic matter level, but in the salt we don't have such type of cations and anions. So based on that, we don't have the much organic matter level on this. Okay, if we talk about the organic matter decomposition, uh, can anyone explain this? Why the organic matter decomposition is rapid in the sand but slow in the clay? Kuldeep, can you guess?
Um, no idea, ma'am.
Okay, Danish, you must know.
I don't know the exact answer, but I try. Uh, is all because of like uh, the particle size or the aeration in the soil.
Yes, the exactly aeration part is important one. So because for the decomposition we must have like either oxygen or some other gases, and based on that the organism can do the decomposition. So if we have the higher aeration in the sand, then the decomposition will be rapid, and if it is like aeration is poor, then clay will have the slow organic matter decomposition. Okay, let's talk about the wind erosions. So stability. So why clay is prone to the not clay? Why silt is the prone to this wind erosion? Why not clay and sand has the moderate effect? Kuldeep, can you guess?
Ma'am, because clay is there is pretty less aeration, and it is compacted and cemented, so it
Yes,
is
yes.
not that much prone to air erosion or air agents.
Yes, and we can also say that because we also saw here now the water holding capacity of clay is high and the drainage rate is very low. So most of the time clay is wet. In that condition, the wind erosion will not give some effect to the clay, right? And but if we have sand, then this wind erosion, there is a two factor, because sand don't have that water, much water in it. So based on that we can say that yes, the wind erosion can be happen, but at the same time we can also say that because the size of this sand is bigger than
Bigger,
this
yeah.
clay, and yes, bigger than this silt and clay, then we can say that it may be possible that wind erosion doesn't have the effect on this sand soil. Okay, so that's why there is a moderate effect on this sand. Okay, if we talk about the water erosion, then it is low in the sand. Why low? Because drainage rate is very high, and even the because of size as well, the water erosion will be low unless fine sand. And for the clay as well, it will be the low. Why low?
Because the particles are not very large.
Because
And because
it
the
is it is
particles are
it
very
is written
compact.
already here. If it is aggregated, if it is a compact, then water will not affect this clay soil. Okay. Then we have the shrink swell potential. We know that clay is the only soil that has this shrink and swelling potential. So whenever we have the wet condition, it will swell. Whenever there is the dry condition or the high temperature, then it will dry and shrink. So the clay has this potential moderate to very high, but for the sand and silt, it is very low to low. Okay. Then the sealing of pond, dam, and landfill. Mayank, can you guess that because of this clay has the smallest particle, right? And because of smallest particle, it can be compacted very hard. And because of compaction, the sealing of ponds, dam, and landfills can be happen. Like it can block some area and it can make some floor harder. Like it can be a sealing material for this pond, sand, and landfill. But in the sand we have the poor sealing facilities. So why it is? Man, can you guess?
Yes, ma'am. Actually, it's due to the compact size of clay, like these
Yes.
particles that are contained in clay. They come in, actually, their density is very high. Their structure is very like crystal. Uh, so, uh, so actually,
Yes.
that's the reason I think. And
Okay,
but in
you
case
can
of sand,
yes.
there is a large size of that atom or that one substance. So
Yes.
that's why.
Yes, and
Mm.
exactly, this is very much related to the size of the particle. So, because we know that in the sand we have the larger size, okay, and when we have the larger size particle, then we have some space in between that, and if it is not because of that space, this will not act like a compact material, and if it is not a compact material, then how it can act as a sealing material for this pond, dams, and the landfill. That's why this sand have the poor sealing facilities for the pond, dams, and landfills. Okay. Okay. Then we have the suitability for tillage after rain. This is good for the sand. What do you mean by tillage? Can Kuldeep explain what is tillage?
Ma'am, these terminologies are new for me.
Okay, so this is related to the agriculture. Danish, can you guess what is tillage?
Yes, ma'am. It is basically from the tilling of the soil. So, like preparing the land for growing crops, something like that.
Yes. Yes, so what we do in the field that we just we facilitate our soil with the oxygen or the air, and in such a way that the topmost soil we make it like not that much hard, we make it soft. So this is a kind of tillage before growing any crop. So we do a tillage mechanism before sowing any type of crop. So sand is suitable for this tillage after rain, but clay is very poor. And why it is poor? Because it has been swelling up. So because of that, tillage is let me explain it more. Like tillage is nothing but we try to make our soil very soft, like the topmost soil, so that the seed can be sowed very easily. Okay, so you also saw that we use the tractors, and we have some we have some tools behind that tractors, and that are making some that are creating a level of the soils, and making some breakage in the soil. So this is kind of tillage. So when we have the clay soil, because soil after rainfall it will swell, so it will not be suitable for the tillage. But if we talk about the sand and silt, then tillage facilities can be happened very well in this type of soils. Okay. Then the pollutant leaching potential. So what it leaching? Kuldeep, can you explain?
Yes, ma'am.
Yes.
So, so here we have high leaching potential in sand because sand is the most
Someone wants to know like what is the leaching?
leaching is infiltration of pollutants into ground.
Okay,
Into
so you are
water.
just saying that if we have a topmost soil here, lower soil here, then when this pollutant and if we have a water or minerals that are present in the topmost soil and that are being penetrating in the lower soil and that has been exhausted from this topmost soil to the lower soil. So this is kind of drainage of nutrients or drainage of pollutant from upper level to lower level. So it is what you are saying about leaching.
Yes, ma'am.
Okay, so it is high in sand. Why?
Because of the highest permeability in sand between these silt and clay.
Yes, exactly. Because exactly, clay has the compacted structure. So how this type of soil will allow any type of pollutant or any type of nutrients to go down. Okay, but in reverse, we have sand and silt that can allow this pollutant to go down. So this is what Kuldeep wanted to say, right? Okay, now because based on this leaching property we can also explain the ability to store plant nutrients. Because there is a low leaching potential of the clay, then we can say that it can absorb more nutrients with it. And in reverse to that, sand has the poor facility and poor ability to store plant nutrients. Okay, then resistance to pH change. Why clay has the highest resistance to pH change? Danish, will you explain? Danish, are you not here? Okay, there may be some problem. Okay, let me explain. Your voice is not audible, Danish. Something has been happened with Danish microphone. No, still I'm no. Okay, your voice is not that much audible to me. Okay, yeah, and because of this rainfall, this can be happened. So let me explain. I already told about this because clay has a different type of cations and anions in it. Like positive and negative charge ions are present in the clay. Because of that, because of some like nutrients and some type of chemical composition we have in the clay in such a way that whenever there is a like change, so this change can be handled by the clay. That's why, and it creates like a buffer condition, like it is resistance to change in the pH. If it is like alkalinity or if it is the acidity, then clay has the potential to resist that change because of the cations and anions. And yes, if we have positive ions, so let's say the negative ions are coming from somewhere, then it will neutralize it. Okay, and if we have the negative charge in our soil, then some positive charge will come, it will neutralize it. So based on that, the alkalinity or the acidity will not be happened in the clay type of soil, and it will create the buffer and the resistance to pH change. But this is not the case in sand and silt. Okay, so these are the properties of sand, silt, and clay soil. So let's talk about soil profile. You already people know. Okay, Danish. So let's talk about this soil profile. So what is the soil profile? It is a vertical arrangement of different soil horizon. So we have to talk about the horizon. So what it is? Horizon, these are the parallel layer to the surface. Okay, so if we have the surface, then we will have the parallel layer of soil on it. Okay, and whatever the layer we have, the property of it is will be different from the layer that is above to it and the layer that is below to it. Okay, so it is same as it has been written, like a layer of soil that is parallel to the surface and the property of which are different from the layer that is above and below that layer. Okay, so these are the horizons, and if we have these horizons, and if we are taking the 3D structure of it, we are taking the subset of the soil, then we will say it is the soil profile. Okay, so we have the O layer, that is the layer that is only composed of the organic matter. We don't have the minerals in it, and we know that we have the four components of soil. The one is we must have some mineral, we must have some organic matter, we must have water and the air. So this is not the true soil actually. Oh, this is the humus layer, and this is either partially degraded or fully degraded, but because we don't have the mineral component of the soil, so that's why this is not the true soil. And this is just like whenever you go to the forest, so there is the fallen leaf on the surface. So this fall the thickness of this fallen leaf will create the O horizon, that is the humus layer. Okay, and I want to know that if we have two different type of forest, one is tropical forest and one is coniferous forest, so which forest will have the thickest layer of this humus?
Um,
Tropical forest.
Ma'am, the tropical one.
No. Guess why? Why tropical forests don't have that thick layer of humus, but the coniferous forest have? There is a reason behind it. Uh, Talk about something about the temperature. The one variable is
Yeah,
temperature. The second variable is the property of the leaf. So based on that, you can tell me. Get
ma'am,
now guess.
because of the decomposition uh, in low temperature region is very, very low. It takes a lot of time. Is it the
Yes,
reason?
exactly. Yes, one reason is this. The second reason is about the structure, about the chemical composition of the leaf. So the first, obviously, you told me that because tropical have the highest temperature and the process of biodegradation by the bacteria is very high, and because of that, this humus layer or the partially degraded part will be degrade very rapidly. But in the case of the coniferous forest, we have the low temperature, and we have the low temperature, then degradation will be not that much fast, and yes, the humus layer will be reached. The second reason is that because we have the resin in this leaf. So what do the resin do? That it resists the biodegradation. Like it is some kind of property that the leaf has. Even leaf has some kind of acidity. So this resists the degradation process. That's why coniferous has the thickest layer of this humus as comparison to the tropics. And sometime it is happen that we don't have this humus layer at all in some kind of forest. Okay, then we have the topsoil layer. This is the outermost soil. This is A. This is the fertile soil, a fertile horizon. Okay, then we have the E. This is alluviation layer where the leaching occurs. From here, the whatever the minerals, whatever the nutrients we have, it will be leached in the down horizons. Okay, then we have the B, that is the subsoil. This is the mixture of sand, silt and clay, and here we don't have much organic matter because this is not have the direct contact with the vegetation and some kind of organisms. So that's why this subsoil is less fertile as comparison to the topsoil. And then we have the sea horizon. This is the unconsolidated parent material. And here the weathering process is very slow. Then we have the R, that is solid parent material, or we can also say it is a bedrock. Okay, so this is the last part of soil, this soil classification. So in the like 100 of year ago, we had a very limited knowledge about the soil. So soil has been classified in a very primitive manner. So the first is based on the fertility. So whether our soil is fertile or not. So when it is a fertile, then we will call it the urvar. Okay, and when it is not fertile soil, it is a sterile soil, or it is not suitable for the agricultural activities, then we will call it the uh, usara. Okay, so this is the based on fertility, but we had some disadvantage while classification, because based on that we don't know what kind of parent material we had, what kind of climate from which this type of soil has been formed. So we had some kind of disadvantage while classifying based on this fertility. So we also came further and we classified soil based on the texture, whether it is sandy soil, whether it is silty soil, clay soil, and loamy soil. But we had some questions that needed to be addressed. So this is not the classification that we needed. Okay. And yes, we also classified soil based on color, red, yellow, black. So we also have some disadvantages for this classification as well. So the advanced classification was based on the genesis, how the soil formed, the color of the soil, and composition, and the location where it is. So based on that, we classified our soil in 8 different parts. Okay, we have alluvial, black, red, and yellow. Only in America based on certain classification. Yes, I know about this. This can be like, we have different type of classifications. So we can classify like in various ways. So this is the classification that is based on the formation of soil, or color, composition, and location. So based on that, we have only 8 type of soils. So first is alluvial, then we have black soil, then we have red and yellow soil, laterite, arid, saline, peaty, and the forest. So here we can say our in India we have the alluvial soil here in the northern plain. Like if we talk about Haryana, Punjab, then some part of Uttar Pradesh, Bihar, we have the alluvial soil. So can anybody explain what is alluvial soil and why it is present only in the northern plain, not anywhere else, but yeah, in this eastern ghat? Yes, Kuldeep.
Ma'am, this is the soil that is carried and uh, uh, what to say,
uh,
reversed by
the
drainage.
Yes,
And
yes.
uh, ma'am, I'm just
So sediment has been carried by a river, and this sediment has been deposited in the path of that river. Is it what you want to say?
yes, ma'am. In the
Yes.
Uttar Pradesh, Indo-Gangetic Brahmaputra plains.
Exactly. So whenever there is a river that is flowing, it will, if it is coming from the slope, steep slope, then it will have a high speed. But when it will come to the plainer area, the speed of the river has been slowed down, and it will deposit whatever the river has been carrying. Okay, so the river is carrying the sediment, some kind of particles. So this will be deposited in that plain area, and this will create a soil that is known as the alluvial soil. So this is the most fertile soil we have in the India continent. Okay, then we have the black soil. We will talk about it later. Then okay, then we have the forest and mountainous soil that is present in uh, Himalayan region, mostly in the Himalayan region. Then we have the red and yellow soil. See here in the eastern side of the peninsular part, we have this red and yellow soil. Then we have black soil in Maharashtra or some part of Gujarat. Then we have the laterite soil. This is near to the Western Ghat, and we have the arid soil near in the Rajasthan or in that desert part. Okay, so let's talk about it one by one. This type of soils, whatever we have. Okay, so we have the alluvial soil. This is the depositional soil, as Kuldeep mentioned. So it is found in delta and river valley and mostly in the northern plain. And it can be sandy loam to clay, and it is rich in potash but poor in phosphorus. Danish, why this is? Like it is rich in potash but poor in phosphorus. Can anybody guess? Danish, Mayank, Kuldeep? Kuldeep, are you here? You
I
are
mean,
not
I'm
here.
here.
You are
I mean, I'm not able to answer this.
okay. So it is just related to water and what solubility of mineral in water. So now you can explain. The solubility of potassium is higher in water as comparison to the phosphorus. Okay, and when there is a higher solubility of this mineral, then it will come up with the water and it will be deposited. But we know that phosphorus is not that much soluble in water. It is always in the rocks and some kind of sinks that phosphorus has. So based on the low solubility of this phosphorus in the water, we have the alluvial soil that is poor in the phosphorus. Okay, then we have two kind of alluvial. Then one is khadar and one is yes, yes.
Ma'am, I have one correction here. Ma'am, the
Uh-huh.
Khadar is the older one and Bhangar is the newer one.
Is it?
Yes, ma'am.
Uh, I think let me see. It may be that I kept it wrong. Khadar.
Yes, ma'am. Father is
He's
the
right. Khadar is
oldest one, and Bangar
Older
is the
one.
okay.
newer one.
Okay, sorry. So there has been some mistake that has been happened. So I apologize for that. So
No,
yes,
ma'am, that's all right.
huh? What happened?
That's all right. That's all right, ma'am.
Okay, and thank you for the correction. So if we talk about the Khadar, then it is the older one, right? And why this is older one? Like how can this alluvial can be older and newer?
Ma'am, because in this Khadar belt there is no more floods. I mean, floods are less than the Bangar one. Bangar region faces flood every year. So every year a layer of soil is deposited, and
Yes. So
that's why it is the
annually.
newer one. Yeah.
Yes. So every time, every year in the Bangar area, we have river that is flowing and it will deposit a new alluvial soil. But because Khadar is away from this Bangar where the river is not flowing, so this deposition of the alluvial will be away from this Khadar area. So that's why this
Ma'am,
is yes.
actually in Khadar region the rivers are flowing from from old, from earlier, है ना? So
Yes.
they create terraces. So the terraces prevents these rivers uh, to broad the flood in the Khadar belt. So these
Okay.
terraces
So
are not present in Bangar belt. So that's
yes.
why there
So
is lots of
So
floods.
this is just like if we have river that is flowing, and it will create the depositional in every side, like this side and this side as well. So what will happen, it will create some terrace.
Terraces, yeah, ma'am.
Yes. So because of that, that Khadir has the older alluvial and the Bangar has the newer. Thank you for answering and correction as well. Okay. Then the soil may have the conquered deposit, and these conquers are made up of this calcium carbonates, and color can vary from light gray to ash gray, and it is the fertile soil. Okay, now let's talk about the black soil. As I showed you in that map, that Maharashtra part, we have the black soil, and this is also known as the Regar soil. This is composed of the clay, and this is deep and impermeable. And clay explain this impermeable property of the soil. High shrink and swell character, as we already talked about it. And because of this, we have advantage and disadvantage. The advantage is that because of this shrink and swell characteristics, in the summer time we will have some cracks in the soil, and because of these cracks we will have the absorption of soil, and self plugging will be happened in that area or tillage that I mentioned. But because if there is the swell condition, then there will be no aeration, and the anaerobic respiration can be happened, whatever the organism we have beneath this soil. So this is the one kind of disadvantage we have in the black soil. Okay, now it is rich in lime, iron, magnesium and potassium, but lack in phosphorus, nitrogen and organic matters, and color vary from deep black to gray, and it cover most of the Deccan Plateau. And I want to know that which crop we cultivate in this black soil.
Cotton.
Yes, so that's why it is also known as black cottony soil, right?
Excuse me, ma'am.
Yes.
I have a doubt in the previous slide
Yes.
that, ma'am, why this black soil have rich in lime, Fe, Mgk? Uh, what
Okay,
may be
rich
the
in
reason behind
what may be the reason. So I don't know exactly the reason. I asked this question from Kuldeep and Danish because I know right now the answer of this. I didn't explore the reason behind it. So Kuldeep, Danish, can you explain
Yes,
the
ma'am.
question? Yes, please.
Okay. So, ma'am, you told us the formation of soil. It very much dependent on the parent material. So
Mm-hmm.
the parent material in Deccan region is from
Igneous
volcanic
rock.
activity,
Yes.
yeah, basaltic
Hmm.
and some other igneous rocks. So
Yes.
which are high in ferrous and these elements. So this
Yes.
might be the reason. I mean, I know about the color and the ferrous richness. Not sure about to put phosphorus, why it lacks in phosphorus, nitrogen.
I can explain about this organic matter because it is igneous in nature. It is hard to wither, है ना? So because
Yeah,
it is hard to wither, then the growth of plant will be limited in that area. And if there is a limited growth of plant, then we can't explain. We can't have the plenty of organic matter in that area. So this is the one reason that can be. Yeah, yes, Danish.
Ma'am, can I also try to answer this question?
Y- Yes, yes, please. Please.
Uh, as we know, the black soil is basically like the parent material of this black soil is the lava rocks,
Ye-
and
Yes.
these are the very hardest rocks, and these
Mm-hmm.
are impermeable. So basically, the minerals or anything, the plants or roots cannot grow, and we know that soil lacks in nitrogen, and some bacteria of the leguminous plants that are like green and blue algae lives in the
Yes.
plant
Yes.
root, and they exchange in the nitrogen fixation. So basically, due to lack of the organisms, due to lack of the plants, they
Mhm.
are very rich in organic matters and nitrogen and other minerals like phosphorus.
Yes, this can be the possible answer. Mayank, are you satisfied with the answer that Danish and Kuldeep gave?
Uh, Actually, ma'am, I want to add a one point here.
Yes.
When the erosion, like lava came out inside the earth, so it
Mm-hmm.
actually contains iron. So maybe that the reason behind it. If
क्या
he
आंसर
did,
आया?
that's why.
Yes. Uh,
Yes, ma'am.
Uzma, are you saying something? Your mic is open. Ujma, are you saying something? Uh, okay. Yeah, Mayank,
हाँ, ए फॉर
I'm
द 32
satisfied with.
लिखना क्या है यहाँ पे?
Okay, let
32 आएगा तो 4 लिख लेना है।
Ujma is saying something to someone, I think.
हाँ, ठीक है, शाबाश। हाँ, ए फॉर द 32,
Hmm,
32 नीचे लिखेंगे।
that's what I'm doing.
हाँ, 2 6 के नीचे आएगा।
I
क्वेश्चन सही
don't have the
लिखोगी तो
mute
आंसर ठीक
option
आएगा।
only for one
हाँ,
person, but I
अब
can remove her from the call.
ये
So
6 के नीचे 2 है। कोई साइडा वड्डा कट्टे
okay, so I removed her from the call. Yes, I'm satisfied with your answer, Mayank, because and yes, answer is very much linked to the parent material because the soil, whatever we have, it came from like the rocks rock came from this lava and igneous part, and the rock has the volcanic form. So yes, we can we can estimate that. Yes, because lava and whatever the material that has been coming from the earth may have this lime, iron, magnesium, and potassium with it. But yes, the root and whatever the Danish told that because root can't penetrate that igneous form of the soil. So based on that, we don't have the organic matter and because there is no any biological activities and there is a that's why there is no nitrogen as well in that black soil. So but you can explore more and you can google more why this is happening, why some minerals are in rich quantity but some are in poor. Okay, Mayank.
Yes, ma'am.
Okay, then color varies from deep black to gray and it cover most of the Deccan Plateau. We are moving very slow actually. Then we have the red and yellow soil. This develop in very low rainfall area as I showed that in Telangana area and in some part of Odisha we have this type of red and yellow soil and these are red due to the iron we have but it become and it appear yellow when this iron material or iron oxide hydrates. Okay, so the color change from this red to yellow. And if we have this fine grained soil, then it is fertile while the reverse is poor, and it is also deficit in nitrogen, phosphorus, and humus. And you must know the reason why it is deficit. You must Google it. I didn't explore it more about the reason behind this. Okay, and this is part in the eastern part of the Deccan Plateau, as I told, that Telangana and this Odisha and some part of the Tamil Nadu, we have this red and yellow soil. Then we have the laterite soil. So laterite later means brick. So this kind of soil is used to make the bricks. And uh, as you can assume, because we are making the brick out of this kind of soil, it means that it is not fertile. Yes, Kuldev.
Ma'am, it is not fertile. Still,
Yes,
in Western
yes,
Ghats, this is the prominent soil found. I
yes,
mean,
and
in the
yes,
rainforest, it is found most prominently. Why it is
yes.
like? I mean, it is not fertile. Still, it has the most canopy. Can you explain this, ma'am?
No, I can't explain this, but yes, we can guess something about it. And this is like the withering in this laterite soil is very rapid. So because we have the high temperature and rainfall, so whenever there is a withering, so we can say that we have some kind of minerals in it. We can estimate it that. And the we have, yes, Danish, what's your question? You are giving the answer for the Kuldeep.
Question. I have some possible answers. As
Okay.
we know that this laterite soil basically develops uh, in areas with high temperature and rainfall. So
Yes.
is that it is poor fertile, but it
Mm-hmm.
sustains a heavy canopy. So might
Yes.
be it is a possible
Mhm.
answer because of the heavy temperature and rainfall, or there may be some like we can say that uh, there is a, like there is a rich biodiversity in the Western Ghats,
So,
like
nahi,
sustaining.
question has been asked by Kuldeep because this soil is already poor in some kind of nutrients or minerals. In spite of that, it has the higher biodiversity or the canopy. So, why it is that? So, this is the question I think, Kuldeep. I'm right?
Yes, ma'am. Correct.
I
Yes.
think the possible answer is because of the high temperature and rainfall, the
Mhm.
biodiversity is sustaining.
Exactly. Yes. So you are just saying that the climate, note the soil, that because of climate, the biodiversity is being sustaining, not because of soil that much. Right? I'm satisfied this answer because of this high temperature and rainfall, we have the like we have the excessive energy and excessive moisture. So based on that, the plant growth can be happened and plant growth can be yes, yes, Kaldeep.
Ma'am, it is not fertile for maybe for crops, but for some trees like canopy. Maybe it is fertile for these plants and trees to grow that are found in Western Ghats.
Yeah, somewhere as well, I also read that because it is not fertile, but it is suitable for the forest. So what happened in the forest, that we have the deeper root of this forest, right? And we also have, like, we have the facility of rainfall. We have the 24 hours, we have the water. So, and temperature. So what's the need of that fertile soil, so it can like the forest can survive. And second answer is that because of that organic matter. Yes, exactly, I the same thing I told, that not for the crop but for the forest it is fertile. Yes. And the second reason can be that because we have the we have the humus layer there. This is very much, but because of that rapid degradation by the organism or by the bacteria, these kind of like, if it is a humus, then we can't use it, we can't consume it. But if it is a bacteria that is rapidly decomposing it, then it is time to time it is giving the nutrients to the plant or to the forest trees. Okay, so if there is a, this is the benefit of that tropical forest. And we if you see that in the tropical forest or in some kind of forest, we don't have that much good soil, but because we have the humus that has been degrading every day, and the nutrients has been like absorbed by the soil time to time, and it is like deabsorbed, it is taken up by the plant time to time. So this is kind of cycle that is happening, and because of that, the forest is there in the laterite soil. So maybe this is the possible answer, but yes, again, Kuldeep, you can explore more about it. Yes, I'm the environmental student and I don't have much expertise in your geography, right? Okay. uh okay, then we already talked about much about this, that we have the, whenever there is a high temperature and rainfall, we will get this type of soil. And Mineral leaching remove lime and silica because we have high rainfall. So it may be happen that in water the mineral becomes soluble and they are leached down in the lower horizons. And because of iron oxide and aluminum compounds, so we will get the reddish color. Humus is fast depleting by the bacteria, and this is also the one reason. Then because depleting is fast, and this humus, that organic matter, because we know we want to get the inorganic minerals to be taken up by the plants. And if we have humus, this can't be taken directly. And if we have bacteria, that is like fast depletion, fast oxidizing or fast degradation of this humus has been happening, then this organic mineral, this organic compound has been changed into the inorganic, and this organic minerals can be taken up fast by the plants. Okay, it is poor in organic matter than nitrogen, phosphorus, calcium, but rich in iron oxide and the potassium, and it is found in higher areas of the peninsular plateau. Then we have the arid soil. I will not explain it much because this is the arid soil, means there is a lack of rainfall and we have the high temperature in that area, and because of that we have the soil that have a very low moisture. Okay, and but the one thing that is important to say, that at the lower horizon we have a deposition of conchers. Okay, and because of that concher deposition, it may be possible that water can be held up above that layer, and because the water that is being holding up in that area, plants can be survive, because this is the height at which root can come and take the water. Okay, then this is found in Gujarat and the Rajasthan part. Then we have the saline soil because we have the salinity in it. That's why we have the saline soil, and this is rich in sodium. Yes, Kuldeep, what's the question?
Ma'am, please show the last slide.
Okay, yeah, yes.
Ma'am, let me read it.
Okay,
Yeah.
just read it. Yes.
Okay,
You can
ma'am.
get my
I read.
you can get my slide online. It is available, right? Okay, then we have the saline soil, because we have the salinity in that soil, and because we have the saline soil, this will create the toxicity in that soil, and this toxicity will make it infertile for the agricultural use. And this is rich in sodium, potassium, and the magnesium. Then we have the peaty soil. This peaty soil is present in the high rainfall area where there is a high humidity and a lot of vegetation. So here we organic material that is being accumulated, and this accumulation of organic matter will give you the black color. And because it is a peaty soil, then it will give you the organic matter content in the high concentration, and this is found in Bihar, West Bengal, Odisha, and Tamil Nadu. Then we have the forest soil. This is the soil that is present in the forest. Okay, and whatever the texture, whatever the structure we have of this soil, this is depend on the local environment. And if we have the, like, in the upper slopes, this is the coarse grained, and in the valleys this can be loamy to silty in nature. Okay, so this is all about the soil. Okay, there is a one more classification that has been given by the this USA Department of Agriculture. Okay, so here it has been divided into 12 orders: antisol, vertisol, insectisol. This, so basically these are depend on the wording. So you have to see what kind of like word we have. If it is a antisol, what it is mean? Verti means turn. Okay, turn means it can be converted from, like, it can be there is a shrink and swelling condition that has been happening in the vertisol. Okay, that's why we will get here the clay or the black soil. Okay, if it is the arid soil, see the word arid means it is a arid. Molysols, moly means soft. So here we have the grassland, and whatever the soil we have beneath this grassland, we will get the molly soil. Okay, if it is a spodo soil, spodo means wood ash, and if we will have wood ash, then it will create some acidic like conditions. So here we will have the acid soil. So you will have to see what kind of word it have in the order. Okay, if it is ulti means ultimate, it is the oldermost soil, it is not the newer soil. Okay, oxysol, like it has the it has been oxidized. Okay, histo means tissue, uh, and tissue means it has the organic soil. So this kind of wordings you have to keep in your mind while learning this kind of yes. Andy Souls means Andy range, in Andy range, and Andy Souls means Andy means black soil, and this black soil come from the volcanic volcanic forms. And if it is jelly, jelly means to freeze, and it is present in this permafrost region. So you have to keep in mind what kind of wording it is and what does it mean. Okay, then okay, explore it more and tell me also about it. So second portion uh, we have spent 1 hour 30 minutes in one part. Okay, so we have second part that is very interesting, the life on Earth. Uh, let's talk about it. So we have the ecological succession. So what it is? What do you mean? Do you know about this ecological successions and what different type of ecological succession? Have you read about it, Kuldeep and Danish?
Yeah, ma'am. Danis has read about it.
Okay. Okay, so we have the ecological session. So definition says it is the process of change in the species structure. Okay, so we are talking about the structure of the species. So for example, in one area, we have like initially we have some grasses, but at the same places, we have some species of tree at the later stages. Okay, so we are changing the structure of the species. Whatever the composition of species we have, we are just changing it. And this we are not changing something, we have some parameters, we have some controlling factors that are making the changes of this species structure in that area. So what is the ecological species? It is the process of change in the species structure of an ecological community over time. Okay, so here it is. First, we have the exposed rock. Like if there is a volcanic activity that has been happened, so we have, let's say, the basaltic rock over here. Okay, in that basaltic rock, we have nothing there. Okay, so but after that, what will happen? Some spores will come from somewhere, and these spores be stay will be stayed in that exposed or the nude rocks or the bare rocks. So what will happen? And whatever the spores of the species that has been coming on that bare rock, it must be very hardy, because it has to be very tolerant to the extreme condition. As you know that, because if we have the exposed rock, we just have the minerals. The soil is not being formed. We have just minerals. We don't have the organic matter. We don't have that much, maybe that much water in that. Okay, so this is the extreme condition. So whatever the species will come on that bare rock, it must be very it must be very resilient. Okay, so the first so we have, and it must be very, it must not be very complex, it must be very primitive so that it can survive. Okay, so lichen and mosses like species will come up on this bare rock or exposed rock. So what will happen? It will like, you people know that it creates some kind of acid, and some kind of weathering will happen over the time, and this will facilitate the growth of weeds or some kind of grasses after some time. And this grass will facilitate, this will make the soil more fertile, more withered, so that these shrubs and tree can be grown up in that area. Okay, so in a specific area we will see, some time ago there was a different kind of species, but after some time we will have the different kind of species in that specific area. So this is kind of the ecological succession, like uh, one species has been replaced by the another species. Okay, so this is kind of the ecological succession. Is it clear, Kuldeep and Tanish?
Yeah, ma'am, very much clear.
Okay. Then we have different stages of the ecological succession. As I told that we have the bare rock, then some lichens will come. Do you know what is lichen? Like what's the special characteristic of lichen we have? What is lichen? Danish, can you explain lichen?
Then lichens are basically
Ma'am, some
small
kind of
organisms that grow on the rock.
Okay, lichen is nothing but we have alga, right? We have fungus. So there is a symbiotic relationship between that. Okay, so fungus, because we know that fungus is not have the photosynthetic activity, but because fungus have some anchor on the rock, so it can absorb the nutrient from the rocks. So because of the absorption capacity of this fungus, this algae can take advantage from this mineral absorption from the fungus. But because we have algae, then algae have the photosynthetic activity, so the organic matter can be come up to the fungus from the algae. So there is a symbiotic combination between algae and fungus, so this is known as the lichen. Okay, and because of that symbiotic combination, symbiotic relationship means both are being benefited by each other presence. Okay, so this is the lichens, and because of that symbiotic relationship, that's why they are very like strong. That's why they are not being affected by the harsh conditions. So first species that come up on the bare rock is the lichens. Okay, then so whatever the first species come up on that rock, we will call it as the pioneer species. Is it is the first to come. Okay, so that's why it is known as the pioneer species. Then we have some different stages, and these intermediary stages will known as the series. Okay, then at the end we will have some stable composition. Let's say a forest has been grown very fully and it is now matured and nothing has been changing, no more stages is been happening anymore. Okay, so we have the stable community at the end. So this community is known as the climax. Okay, so you have to keep in mind the first species is known as the pioneer species. The stable community at the end will be known as the climax community, and in between that we have some stages, and these stages are known as the series. Okay, so let's talk more about this pioneer species. As I already talked about it, it is the hardy species which establish themselves in the disrupted ecosystem and trigger the process of the ecological succession. And what are the characteristics? It has the ability to grow on the bare rock, because and this bare rock has the nutrient poor soil or the water, ability to tolerate extreme conditions such as heat and cold, less nutritional requirement, because if it has a higher nutritional requirement, then it can't grow on the rock. So the pioneer species must have the less nutritional requirement, and we are preferring the photoautotrophs as a pioneer species because they can prepare their food themselves. Then we prefer very small size species as the pioneer species. And here in the pioneer species, we have very short lifespan with rapid growth. And mostly annual species. Annual species means they just grow in a month or and they die within a year. So these are the annual species. And they have the ability to disperse through spores and seeds, and prolific seed production is happening. And because of that seed production and all, the bare rock has been covered by this pioneer species, right? Now we have Siri. I already talked about it. These are the intermediary stages that found in the ecological succession in the ecosystem, advancing towards this climax community. So we have different type of these stages. If it is related to the water, if we have the communities, these communities in the water, then it is known as the hydrosphere. If this is the dry air, then we will call it the xerosphere, and in xerosphere we have the lithosphere and the samosphere. So lithosphere is like on the rocks, and samosphere is, can anyone guess? Kuldeep, Danish, what is samo?
We don't know.
This is on the sand. If the community is on the sand, then this kind of community, this kind of the series will be known as the zero series. And if the community is on this saline body, we will call it the hello series. Okay, then this is kind of example of this hydrosphere. Here we see we have the clean pond. Then after, because we know that this is the photosynthetic area where we have the higher amount of sunlight, then some kind of phytoplankton will grow here, and because of after dying of this phytoplankton, subsedimentation will happen bottom of this lake or the pond. So slowly this sedimentation will increase, and the rooted submerged stage will be come up in that area. After that, this sedimentation will grow again, and now we will have the plant that are rooted, but that has come out from the surface of this water. Then what will happen? Then we will have some grass like grassland kind of situation. So this is the reed swamp, or the swamp or marshes type of stage we will have. Then this is the reed swamp stage, or and the sage marsh or middle stage. Then this will convert into the woodland. So this is the example of the hydrosphere. From here, from there to there, 3 to 7, there is a hydrosphere, because here we have the pioneer species that are the phytoplanktons, and then we will have the woodland that will make up the climax community. Okay, now we have the climax community. I think I already have talked about this, so can I skip it because we have more content to read about?
Yes, ma'am.
Kuldeep, or do you want to know about it more? Okay, Kuldeep is not answering, so I think I must skip it. So we have a different kind of climax community. Some climax community are controlled by the climate of that region. If these are being controlled by the climate, then we will call it is the climatic. And likewise, if it is controlled by the soil condition, then it will be the adaphic. Okay, Danish. Then we have the catastrophic climax. This is controlled by some catastrophic events. For example, if a wildfire is there, then this climax community will be controlled by such kind of events. Then we have the disclimax. If there is some kind of disturbances, for example, if man is doing some kind of activities within the forest and it is changing the climax community, or it is climax community is being driven by such kind of disturbances, then we call it as the disclimax. Okay, then we have some theories about the climax, because some ecologists said that we have only one type of climax. Okay, some told that no, there are different type of climax. Some told that these climax are controlled only by the climate. Some told that no, these are controlled by the soil, these are controlled by the topography. So many ecologists argue and come up with some kind of theories. Okay, so we have three theories about this climax. So first theory is the monoclimax or the climatic climax. So from here we can see mono means there is only one climax community. Okay, and this climax is solely controlled by the climate. Okay, so whenever this is happening, then we will call it is the climatic climax. Okay, It has been given by the Clement in 1916. Then Tensley came up in 1935, and he told that no, we have more than one vegetation climax, and the theory is polyclimax. Poly means many, and because why there is the more than one vegetation climax, because these climax are determined by soil moisture, soil nutrients, topography, and various different type of variables that are controlling the vegetation climax. But at the end, Whittaker came in 1953, and he came up with a theory that merged these two theories. So he told that yes, this climax can be more than one type of vegetation climax, but they are largely controlled by the vegetation. Okay, so he just merged these two type of theories, and this is climax pattern theory. Okay, now we have two different type of succession. One is primary and second is secondary. So Danish, do you know about it? About it is primary and
Yes, ma'am.
secondary.
Yes,
Yes,
ma'am.
what it is?
Ma'am, basically, primary succession starts in lifeless areas.
Exactly.
For example, when lava cools and creates new rocks, so or when the glacier retreats and a new land is formed. So the process of life gets started by lichens accumulating, like the pioneer species are accumulating further the intermediate, and then a climax species dominate over that period.
Yes, exactly. And what is the secondary succession?
And secondary is basically when a climax community or the intermediate community which is impacted by any disturbance, for example a forest fire. So this type of succession is coming out of a climax
Uh-huh.
succession. It means that it is not started from a lifeless area, it is started
Uh,
where a, a period before life was sustained. So basically, it is the secondary succession.
Okay, you are just saying that if we have a bare rock, if we have nothing on that area, then we will have the primary succession, because it will start from very primitive species to the climax. But if we have some if we have some condition that at some stages something has been happened, some disturbances has been happened, so from wildfire has been happened, so here soil is already has been formed. Okay, so this is kind of the secondary succession. And we also have the cyclic succession, just like the Brahmaputra plain. So annually what happened, like whatever the vegetation we have in that area, so it has been removed and die off, and the newer grasses grow there. Okay, so this is kind of cyclic, because it is happening every year or after some period of time, and but this is the regular period, so this is the cyclic succession. You already have talked about this primary and secondary succession, so we can move further. Then we also have two different kind of succession, that is autogenic and allogenic. Am I audible to you, Danish?
Yes, ma'am.
Okay. Then we have the autogenic succession. Whenever the biotic factors we have, the because of that biotic factor, that succession is been happening. Like lichen is creating some kind of condition in such a way that the herbs or the shrubs will replace these lichens. So this kind of conditions that has been happened because of this biotic factors, so this will be the autogenic succession. But if outer or the external disturbances or external things that are creating a succession or the abiotic, then we will call it is the allogenics. Let's say volcano or the flooding, something is happening, or the human interference that doesn't involve the plants. Okay, and so this is the allogenic. So this is basically about what type of like who is owning this succession. who is the what factor we have that is just controlling this succession. If it is a biotic factor, then we will call it is the autogenic. If it is not the biotic factor, then we will call it is the allogenic factor. Then we have some phases of succession. Can you explain one by one this, Danish? What is nudation, invasion, or
Ma'am,
yes?
read about this. Ma'am, I
What?
haven't read.
Okay,
Ma'am, I haven't read about the phases of succession, so I don't have any idea.
okay. So nudation means if we have a bare rock, okay, because rock is nude, then we will the process of formation of this rock and this bare rock, we will call it is the nudation. My voice is audible, right?
Yes, ma'am.
Okay, Kuldeep, now you are here. Okay, so now we have the bare rock. So the formation of this bare rock is known as nudation. Okay, the formation of some new habitat. Okay, then some species, some spores will come from somewhere. So migration will happen. So either it is a migration or the invasion. Okay, so this is something has been come up from somewhere. So this is kind of migration that has been happened at that place. So this is the invasion or migration. Then we have the EACs. EACs is the germination. So if we have a spore, then this spore will germinate. So just so the process of germination at that place is known as the EACs. Then the germination of many kind of spores or the kind of organism will be happen, and it will create a kind of community. Okay, so this is known as the aggregation. So many species will come up and will survive here. So this is the aggregation. But because there is a limited resources at that place, so there will be some kind of competition among that species. So after aggregation, after the establishment of many plants or organisms, there will be a competition. After that competition, because some have to adjust, some will be extinct, something will happen. Okay, so there will be kind of reaction. Okay, so natural selection can be happened there. Okay, some species maybe come out as very hardy and very resilient or resistant to any kind of change. So a stability kind of condition can be happen, because every species will find some solution to survive there. So a kind of stability or the stabilization will happen at that stage, and then we will come up with the climax, and that is the equilibrium stage. Then where we are assuming that there is a no any kind of the changes. Okay, these are the nutrient cycle. You people all know about it. How the, because this is important. Why? Because we have the plants, we are talking about the vegetation, we are talking about the life, and life is life is possible when there is minerals that are being transported from somewhere to our body. Either it is the body of the vegetation or the animal. Okay, so we must know the flow of this nutrient from one compartment of earth, like from atmosphere to hydrosphere to lithosphere. So how this mineral flows from among this compartment of earth. So that's why we study about this biogeochemical cycles. Okay, so this is the pathway by which a chemical substance such as mineral move through a biotic and abiotic compartment of earth. Then we have the nitrogen cycle. I think you people know about nitrogen, carbon, and phosphorus cycle. So can I skip it
Yes,
or
ma'am. Ma'am, you
okay,
can skip it.
Yes, ma'am, you
okay,
can skip
let's
it.
skip it.
Yeah, ma'am, skip it.
Okay, so this is interesting part, and we have a very shortage of time to complete this biodiversity. So what is biodiversity? It is a variety of life in all of its form and at all level of the organization. So there is a three word that we have to keep in mind. Variety, like we have different kind of something. Okay, so a different kind of life. The first part is this. The second is life in all its forms. So what this forms is, either it is plant or it is animal or it is fungi. So all form of life. So variety in all form of this life, the one thing. Then at all level of the organization, either it is the genetic level, either it is the species level, or either it is a ecosystem level. So there must be a variety, and then we will call it is a biodiversity. So I think in 8th or 9th class you have read about it, right? We have like we have this archibacteria, eubacteria, protista, animalia, fungus, and plantae.
Yeah, ma'am.
Okay, and in animalia we have uh, two different type of classification based on like whether the organism have the backbone or not, whether it is vertebrate or invertebrate. Okay, so the classification is based on this. I will see. Okay, so the classification of animal is based on either the organism has the backbone or not. If it has a backbone, then we will call it the vertebrates, and if it doesn't have the backbone, then it will known as the invertebrate. And in the vertebrate, we have the cold-blooded and we have the warm-blooded. So what do you mean by cold-blooded and warm-blooded? Can someone explain very fast?
Yes, ma'am. Warm blooded means warm temperature of blood, and cold blooded means the temperature will be low.
Yes, but how this is possible? We are the cold-blooded. How, why we are the cold-blooded and not the, sorry, why we are warm-blooded, not the cold-blooded?
No
There is a
idea.
there is a terminology that is known as thermostatics.
Yes, ma'am.
So what it is like regulation of the temperature by the body. Okay, if there is a regulation of temperature in the body, then we will call it the warm blooded. And if the organism that can't control the temperature of the body, then we will call it the cold blooded. So for example, we have the reptiles such as snake. Why snake hibernates? Why snakes are burrowing under the soil in the winter time? Because they can't regulate the temperature, and outside it has the low temperature, they can't survive. Okay, so that's why the hibernation or some kind of mechanism they follow to protect themselves. But we humans have this property, that is the thermostatics, in which we can regulate our temperature, and we are the warm blooded. If it is the cold temperature as well, our body can maintain a specific kind of temperature. So mammals, birds are the warm blooded, but the fish, reptiles, and amphibians are the cold blooded. And invertebrates that doesn't have the backbone, we have the jointed leg. Insect mostly have the jointed legs, and if we don't have the jointed leg or without the legs, then these are the worms like, or some other type of worms that are within this invertebrates. Okay, now we have the plant kingdom, and this is based on like plant without seed or with seed. If it is without seed, then it has been divided into thallophyta, mostly the algae, then the bryophyta, and then the pteridophyta. This fern-like plants come under this pteridophyta. Then we have the phanerogams, in which gymnosperm and angiosperm come up in the and this is based on whether they give the fruits or not. And so angiosperm give the fruits, so these are the angiosperm, and if they don't give up the fruits, then this is the gymnosperm. So this can you see the variety of life we have, like in the animal we have a variety of life, in the plants we have a variety of life. So these are the forms of life. So when there is a diversity in this form of life, then we will call it the biodiversity. Okay, and the second part was the diversity of life at different level of organization. Okay, so yes, yes, please. So if we have a genetic diversity or species diversity, and ecosystem diversity is based on the some level of the organization. Then we have the species diversity. If we have a different kind of species, for example, if we have a mango, so mango is a genre, not a species. But if you talk about different variety of mangoes you have in Uttar Pradesh or Bihar, so you are talking about the species. So how many species you have? So this is kind of the species biodiversity. And how will you explain the species? A species is just like when two organism can interbreed, then we will call it is a member of the same species. And species biodiversity, as I already told, how many species are there and how they are distributed. This is very important, how they are distributed. Like if we have four species and one species occupy the 90% area, and the three species occupy only 3% area, and we have the second condition in which every species occupy the 25% area. So we will say that the biodiversity in that first area is greater. No doubt we have the same number of species, but we will say that biodiversity is higher in that area where there is a 25% each species, in spite of the area where there is a one species that is 90% and other species are very marginal. Okay, so this is what it is, the distribution. So this is the kind of distribution that I explained it right now. Then we have the genetic biodiversity. This is some kind of long, because I thought that you people are from the humanities background, so you people may know about the genes or DNA. So let me explain it about this. So can somebody explain what is gene, what is DNA? Kuldeep, briefly. Danish, yes, yes, Kuldeep. Want to speak something about genes?
Um,
Like in ninth or 10th class, you read about the gene, DNA, what
yeah,
it is.
ma'am, I think you are getting late. So,
Yes, I'm getting late, but yes, I can ask questions from you. I have that much time to ask question from you people.
Basically, genes are the physical and functional unit of heredity, and
Hmm.
heredity is something that is transmitted from parents to offspring.
Okay, so let me explain it. We have a cell. We already read it in the 8th or 9th class. We have a cell. In cell, we have the nucleus. Okay, in nucleus, we have the chromosome. So chromosome has the DNA part and some kind of protein. Okay, so we have DNA in the chromosome. So this is the structure of the chromosome. Okay, and you know this is the double helical standard structure, because we have two strips that are like moving just like this. Okay, so this is the double standard strips that makes the DNA. And in DNA we have amino acid, we have phosphate, and we have some sugar, and because of that sugar we got this name DNA, right? Then because we have a DNA, a very long DNA, and a segment of that DNA, a small segment, then from where we can infer some kind of information. So that short segment of DNA is known as the gene. Okay, and we may have different kind of this. We may have different kind of gene in one organism, in the another organism. And for example, if we have a color of a hair, okay, it can be burgundy, it can be black. So these this segment that is part of the DNA may have some different code, and that code is making my hair black. But if you people have the burgundy, then this will have some different kind of codes that will make your hair burgundy in color. Okay, so we must have a different variety of these kind of genes. Okay, and this is very important. You know, in agriculture there is a like we are creating some kind of, we are modifying our plants in such a way that if there is a high temperature, then we can resist this harsh effect of this climate or this temperature. So what happens, that if we have a variety of genes, then among that we can select the one gene that is resistance or that is not prone to the climate. So we must have a variety of genes. So this is nothing but the genetic diversity. This, you know about this DNA and how this DNA forms the proteins. I think you people know about it. Then we have the example of genetic biodiversity, polymorphism, and heterozygosity. I think you people may not know about it because you are not the biological people. And this is not also important for you. So let me skip it to just complete my syllabus. Then we have the ecosystem biodiversity, where if we have a different kind of ecosystem in on our earth, then we will say that we are rich in ecosystem biodiversity. And if we have only, let's say, the forest ecosystem everywhere, we don't have the pond ecosystem, we don't have the river ecosystem, then there the biodiversity is less. Then we have some measure of biodiversity, and we can calculate it using some indices, such like a Simpson diversity index. I can explain in better way, but I have shortage of time. So this is kind of some formula, 1 minus summation of n minus n. So here we have some, like how many individual of a species we have upon the total number of individual we have. So based on that, we can know the proportion of each species in that area, and based on that we can calculate the diversity index, that is known as the Simpson diversity index. Then we have the Shannon diversity index as well. There also, here we have the proportion of ith species, just like we calculated n by the capital N, and the summation of this pi and the multiplication of the natural logarithm of pi. So this is the Shannon diversity index. Then evenness index can be calculated from Shannon as well as Wiener, and it is like h upon me h max. H max is the maximum possible value of this Shannon diversity index. I'm just skipping it for very fast so that I can complete it on time. So we have three different type of biodiversity: alpha, beta, and gamma. If in a if we have 1 hectare of area and we have 10 different types of species in that 1 hectare area, then we will call it is a alpha. So in alpha we have the 10 species. If we have two different kind of, like 1 hectare we have here, 1 hectare here, and we have 5 species here, 5 species here, but there is like 2 species here that is common. Okay, so that common will be removed from there. So what new species we have in that two communities, then we will call it as a beta. And whatever the species we have in a geography, the total number of species, this will be known as the gamma. Okay. Then we have the biodiversity hotspot. You people know that whenever there is a high species richness, there is the endemism. I think you people know about endemism. If it is not known, that I can explain.
Yeah, ma'am, we know about it. When
Okay.
some
Yes.
to extent.
For
When it is
example,
always, for example, we have rhinoceros.
rhinoceros. Yes. So if there is a species that are not present anywhere else, if there is located at a one specific area, so this is known as the endemism. So
Yes, ma'am.
if there is an area that has the high species nicheness, then there is a high degree of endemism and high degree of threat as well. Then we will call it as a biodiversity hotspot. And how many hotspot we have in India?
Ma'am, we have 6, but some says 4.
Yes,
Okay,
ma'am.
some says 4 and I also say 4. So
Yeah.
what are these?
Let me name these: Himalayan,
Mm-hmm,
Western Ghats,
mm-hmm,
Tarai, Indo-Tarai region,
mm-hmm.
Sundarban, and And we
Sundarban
have
is a part of northeast hotspot region.
Indovarma and Sundaland.
Yes, yes, exactly. So we have the four hotspot in India. And there is some hypothesis behind why there is a hotspot. Like why there is a high biodiversity in that region only. So some people gave some hypotheses about that. These hypotheses are like we have five hypotheses. After that, we have nothing to teach. So we have
Ma'am,
evolutionary. Yes,
ma'am, we will
you have.
take a screenshot of it if you
Okay,
have
okay.
to do so. Yeah. Yeah.
Yes, yes. So we have hypothesis. You can let me know if this is not clear in the next session. And then this
Yeah,
is the
ma'am.
assignment. Can you solve it very fast in 1 minute?
Yes, ma'am.
Okay. So first question, Kuldeep, complete it.
Gamma, ma'am, gamma.
The biodiversity that exists among different. Yes, this is gamma. Danish, what's the answer for this second?
Second one is physical.
Huh?
Physical.
Physical. Yes. Kuldeep, third question.
Alluvial.
Pangar is a type of alluvial, right? Regur is a term for Danish.
Black
Uh,
soil.
Black cotton
Oh,
soil.
it was Danish turn. Okay, Khadir is a type of Kuldeep.
Alluvial.
Alluvial.
Ma'am, what is the answer of Ragur?
What is the answer of?
Ragur soil. Ragur is the
This is
term.
black cotton soil.
Okay,
I also this was first line in my slide that black soil is also known as Regur soil.
okay, ma'am.
Okay. C refers to
Uh, ma'am, the
Substratum.
subsoil maybe.
subsoil or substratum.
Ma'am, substratum. Ma'am, subsoil is
It
the
is
B.
substratum. Yes. B is subsoil and
Okay.
C is substratum.
Yes, ma'am.
Okay. Now soil formation is dependent on.
All of
All,
the above.
all of the, all of
Ah,
the above.
okay, you people know. Okay, self-plugging character is seen in. I told about it.
No idea.